Hi everyone. Thank you for taking your time for our session from siloed ML to ML service mesh using API management. I'm Kaz Sato, developer advocate from Google Cloud based in Tokyo.
I'm Rakesh Taranki. I'm Google Cloud Architect in Apigee team. I am in Atlanta, Georgia.
In this session, we'd like to cover these topics. First, I'd like to discuss about how you can build a scalable machine learning production system with Google Cloud's AI platform. Then I will discuss about the second problem that is called siloed ML and how you can solve that by using ML service mesh. In the latter part of this session, Rakesh will discuss about API management and how it can help building ML service mesh. So let's start discussing about how you can build a scalable machine learning system with AI platform. Now, many data scientists or companies are trying to bring the POC system into a production machine learning system. But those POC or prototypes can be all covered by the single data scientist. But for production system, you have to split the responsibility into the multiple roles. For example, data engineer can be responsible for ingesting the data from the data warehouse and apply some pre-processing against that, whereas data scientists and ML engineers can be responsible for training the model, design the machine learning model, get the higher accuracy, and they push the training model into the system. And then ops engineer or ML engineer can be responsible for designing the scalable and continuous training and prediction system. Let's think about a scenario where the data scientist is visiting a cubicle of the ops teams to ask to bring his the POC systems into production system. What kind of the problems the ops team have to solve? There are many different gaps between POC and production. For example, many POC notebooks can be locally dependent or dependent on a single person. But with production system, you have to make everything portable and shareable. And you cannot rely on a single notebook instance anymore. You have to think about build a cluster of those multiple instances with the scaling out or scaling in functionalities or load balancing of the incoming prediction requests. And everything should not be dependent on a manual process. Everything should be reproducible for the end-to-end machine learning lifecycle. And lastly, you have to think about monitoring so that ops team can be responsible for the continuous monitoring and alerting for the continuous operation. So those are the reasons why Google provides a product called Cloud AI Platform that has two features, training and prediction. Those are managed services for machine learning training and prediction. For example, if you are using machine learning prediction of Cloud AI Platform, then you don't have to spend your time for building a scalable prediction infrastructure by yourself. Instead, the managed service can take care of the adding more instances or removing the instances based on the current workload you are getting for the prediction system. And also, it can provide the distributed GPU and TPU training service, so you can easily get the distributed GPU environment without spending much time on building a GPU cluster. And also, the service can provide the logging features using the BigQuery data warehouse, so that makes it much easier for building a continuous monitoring setup. So by using Cloud AI Platform, you can easily get those benefits required for the scalable machine learning system. That includes the scheduling of all the instances, lifecycle management of those containers and instances, scaling out and scaling in functionalities, load balancing and dispatching the workloads, logging, monitoring, troubleshooting, and security. You don't have to build those features from the scratch by yourself. Instead, those features are already available in AI platform. But for the large enterprises, that is not the end of the story. So for example, let's imagine a scenario where you have just finished building a machine learning pipeline for a single service like recommendation. If it's a large enterprise, Then you have to move on to another project like ads optimization. Then you have to build another service, fraud detection, demand forecasting, customer support, research, and so on. So without thinking about sharing any intermediate result or assets, you'd easily end up with having multiple silos of machine learning pipeline. That is an anti-pattern called siloed ML. So for example, for building a recommendation system, maybe you are getting the user profile or user vector from user activities or product vector from product description to train a model for the recommendation service. So the solution could be building a machine learning service mesh. You could start with building a monolith kind of this service that has everything inside it, but gradually you can split your responsibility into the multiple microservices. And eventually you would have the bunch of the microservices that can be easily composed to build a final the machine learning service for the clients or consumers. For example, in case of the recommendation systems, rather than building the monolith of the recommendation systems, but you can split those services into the three microservices. The microservice, the ML service A can predict a user vector from the user activities. Service B can predict a product vector from product description. Then you could have another service C that can take those user vector and product vector to provide a recommendation result, so that you can easily reuse those internal assets like a user vectors and product vector for the other purposes. So this is the solution called ML Service Mesh, but the missing link here is the API management. And why is that? Because if you are working for large enterprises, you have to think about how to share those assets with a proper business model and security model. You cannot just expose your APIs without any the tracking and monitoring for that. So missing link here is the API management for the ML Service Mesh. So I'd like to pass the screen to Rakesh. He'll be discussing more about API management.
Thank you, Kaz. So let's continue with the discussion where Kaz stopped. So we have the ML pipelines. You want to introduce them as part of your enterprise consumption. So how do you go about, right? You might have internal consumers, mostly for the ML pipelines. It might be internal consumers, but you might also have the external consumption, the third party, where you don't have control, right? So the idea here is, how can you take your pipelines, or it can be other services, and make them easily consumable by your consumers without any friction, ideally in a self-service mode, right? So this is where we're going to talk about on how to make it happen. Most of the companies, most of the enterprises are in this journey moving from monoliths into microservices, right? Maybe some companies are halfway through to service-oriented architectures, but still the journey is going on into breaking down monoliths into smaller services. Well, the idea here is to make your services fine-grained and make the communication protocols between these services lightweight and simple, right? And also, many of the enterprises are making the assumption that the trust is established between the services without actually enforcing policies. So the idea of a good microservices architecture is to increase product velocity, right? You want to release your features as often as possible, manage complexity of the code, right? And you want to admit heterogeneity, right? Each developer has their own tool sets. Maybe they like Scala, some teams might like Java, some teams might like .NET, right? You want to admit that. And then you want to apply security policies, very, very important. You want to enable that trust through enterprise security policies. And then at the same time, you want to empower your developers to be as quick as possible and as independent as possible. So this is how an enterprise services can look like. You have multiple services. They're all communicating over APIs. And by default, APIs becomes a communication contract between services, right? Every system that can receive requests has some kind of an API. They can be RESTful, they can be SOAP, or maybe 1,000 different ways of doing APIs. Or maybe they're using GraphQL, gRPC, YAML, right? So there's a mesh of services within the enterprise. And then when a consumer from outside or from inside calls an API, they orchestrate the calls within the mesh and get back with a response. So we are getting into some kind of a mesh here. Let's see how to enable this, right? Let's dig in deep a little bit. We have service A, we have service B. Now these are microservices. How do you enable communications with them? The best way is to have mutual TLS, right? Ideally, you want to have certificates for each of these services. And once you have unique certificates, you can enable those certificates in the other services, right? And you also want to introduce centrally described communication policies like, retries, timeouts, circuit breakers if a call is taking too long, right? You want to enable routing so that if the services are located in different regions, different teams, to enable the routing in an efficient way. And on top of it, you want to enable auth and the authentication authorization. Right? Maybe not every service is consumable by every other service, so it's very important you authorize those services. Right? When this is happening, you want to collect analytics and also monitor the services. You want to know at any point in time whether the service is up or down, right? And at the same time, you want to enable some kind of telemetry so that you know who is consuming what at any point in time. So we need a sort of a support system to enable this. Let us see how to make this happen. Right? So let's delegate all this complexity of these communication protocols to a standalone, something called Envoy. Right? Envoy is a high-performance pluggable proxy providing improved networking and observability for increased service communication. Right? So this is built, Envoy is built on learnings from HA proxy and Nginx. Right? Envoy is very popular and widely used, and it's very widely used inside Google also. Envoy uses what we call it as sidecar pattern, right? In this sidecar pattern is better than embedding different libraries and making it a big monolith. So with this pattern, right, it's easier to support services implemented in multiple languages, and also you can update the proxies independent of other services, right? So this is where a good control plane will help you to manage your services. So me as a data scientist, at this point, I'm thinking, is this challenging or is this simple, right? Now, a model has become part of a mesh architecture. It's no more a silo, right? So models are part of a big piece in the enterprise. So let's start digging deep now. We want to introduce the control plane, which is a service mesh, right? What does service mesh help us to do, right? It will help us to connect between the services, right? The flow of traffic between services. It will help to secure the endpoints between the services and encrypt that communication, very, very important, right? And you want to control this by applying security policies. Right? And then you want to observe and collect metrics for monitoring and analytics purpose. Let's dig in a little bit deep, right? This is where Istio comes into play, right? Istio starts with the Envoy proxy as a sidecar pattern, and then adds a set of policies to help and manage and provision the distributed set of proxies. As you can see in this picture here, right? You have the Envoy, you have the control plane, and then we'll also introduce what is called as API management layer here. All right, so let us talk through this, how an API management layer will help you, right? You have the services and you want to enable them both for internal consumption and your external consumption. And let's talk through an example and I'll explain to you on how the API management layer will help you to do this. So let's take this example where you have a legacy app and you have a monolith app, right? And you have your consumption layer, right? All these modern apps, you have the legacy apps, and then most of the enterprises have an API gateway, right? In this case, Apigee API gateway is a GCP offering to provide you a full-fledged SaaS offering to manage APIs. Most of the enterprises enable their services through the API layer. API layer kind of acts as a switch to switch between different services in the backend. And then you have your internal apps. Most places, internal apps are directly going against the services. There's not much of API management going on in that layer. Now, let us go through this journey of breaking down a monolith into microservices. So let's take the monolith 2 and break it down into smaller services. At the same time, you're updating the internal app to consume your microservices as well as the monolith. And at the same time, you're updating your gateway to also use the services, the new microservices. And in the process, what you're doing is you're introducing new capabilities by adding more microservices. And also you're introducing ML pipelines, right? Using cloud ML platform. This is where you're adding more capabilities, where your internal apps are being updated to consume these new capabilities. And at the same time, you're keeping it transparent for your external consumption to use the newer capabilities, right? So this is, as you can see in this, the onset of proliferation of different services. So this is a problem, probably a good problem to have. Let us see how we can simplify this. So this is where Istio control plane will help you to build your service mesh architecture, right? In this diagram, you will see the service mesh is kind of helping to manage the communication between the services, right? You also see the legacy systems using the legacy services being exposed to the gateway to the third-party system, right? And also the internal apps are using the legacy, but at the same time, the internal apps are now consuming the services from the mesh, right? And in fact, the gateway is acting like a nice little switch to switch between the legacy and the newer layer of mesh architecture. You can also see what is called as Apigee adapter. And this is where you get the API policies. Now, what does the adapter help you to do? It will help you to centrally govern or manage APIs, right? It enables API publishing, visibility of the APIs, right, by publishing them into portals, enables governance, good governance by applying your best practices, and it collects the analytics. Specifically from a security perspective, the adapter will help you enforce in the Envoy, like things like verifying the OAuth token or the API keys, right? Checking if there's enough authorization to consume the services, right? And other things like a quota. If you have some kind of a quota on the service, it will enforce that. If you have rate limiting, it will enforce that. If you have like threat protection to validate any threats coming on the APIs, it will enforce that. So basically, adapter is helping you to do these kind of security policies, right? And Istio Service Mesh is helping you to enable the communication between the services. This is kind of a clean model and where the separation of concerns is very clearly maintained. So let us understand how this is happening. So Envoy supports a long list of filters, and these filters are written in C++ and compiled into Envoy itself, right? Apigee adapter uses a one specific filter called as external authorization, external auth filter, which is designed to allow Envoy to delegate authorization decisions to an external system. This is where Apigee is registered and gets a control. So let's see how the traffic flow happens here. So when API call comes into Envoy, right, the Envoy gives the control to Apigee adapter, right? In this case, we call it as Apigee remote service, right? Apigee remote service will go back with either A or a nay, right? So what it will do is it will enforce the policies that the API publisher has designed for this particular API consumption. So it can be OAuth, it can be quotas, site production, rate limiting, any policies they have. It's enforced here. If the adapter responds back with the A, then it'll go back to your backend service, and then the call is processed in your backend. If it is an A, then an error is sent back to your consumer. Right, so Apigee remote service is acting as a policy decision point, and adheres to Envoy to allow the API consumption or not. Now, how does this work in a very high-performing system? How can you get those hundreds and thousands of TPS in an API call? Right. So the communication between the proxy and the Apigee remote service is gRPC. So this is very good for speed and efficiency. Right. And then the Apigee remote service talks to its management plane and downloads anything that is required to make the decision, which includes the policies, right, keys, products, anything that's required. It's all cached inside the remote service. So this is how this is how the Apigee remote service is built for a high-performing support system. So let's try to bring everything together. So why use API management in your service mesh? Right? So you don't want any of your services to be in a siloed, right? Whether it is your cloud AI prediction models, or whether it can be a microservice, it can be anything, it needs to be discovered. And how do you discover them? So with Apigee, you can have a portal where you can publish all your services, right? And this portal can be designed in a way that the consumers can act in a self-service way. There's no more whitelisting the firewalls, or whitelisting your APIs, right? Someone can come and say, I need access to certain APIs, and then your API producer can get a request, and then they can approve the request, right? And then you can modernize your services. All the stuff on the legacy, your old monolith applications, everything can be hidden by nice little APIs using REST or any standards that you use, and expose them in a good way. Right, and then no more exchanging those PDF files or Word files, right? You can have nice documentation wherein you give the required technical aspects for the API, and the consumer can come in and try those APIs before even they use it in the application, right? And then you can have reports on the services. This is very, very critical. At any point, you should be able to answer the questions like, who are my top 5 consumers, right? Or what are my SLAs that were satisfied today? Or what was my performance, right? What kind of products were used from a business aspect? So you should be able to answer these kind of questions using the analytics that you covered. And in a large enterprise, governance becomes very, very important, right? You want some kind of best practices enforced across the teams, and this is critical. You can enforce things like CI/CD, linting, right? Code standards, all these kinds of things across the enterprise. You can enable and enforce them. Right. Once you have the APIs, it's very, very critical. You monitor them. At any point, you should know which service is up or which service is slowing down before your consumers tell you, which is very, very important. And then once you have this nice little system working, you want to start making money out of it. You want to accept a credit card and start charging your consumers. And this is where the monetization module in Apigee comes into picture. You can plug it in and define your policies on how to monetize your APIs. Maybe not all APIs need to be monetized. Maybe you pick a few business APIs which are critical. You only monetize a certain set of APIs. These kind of behaviors can be brought in with a good API management layer. So we have a solution page which ties up all this, and you should be able to try it, build a prediction model in the Cloud AI platform, and then expose that AI model using the Apigee engine, and then send it to your consumers. So all this in a frictionless way. We have a solution page explaining all of this. I would say the biggest takeaway for you in this session will be, once you have these models, how can you models or other services, how can you make your consumption of these services seamless, frictionless, right? You want the consumption to be the easiest of all, so that your services are actually consumed a lot faster, giving the benefit to the enterprise, right? The impact is a lot more faster if you remove those kinds of friction. So the biggest takeaway will be, how do you bring in your services in a way that can be consumed without any friction? Looking ahead, we have a solution page where you can try this sample example, where you can try the AI platform and Apigee. We have step-by-step instructions. You can get a free trial account. You get almost all the features in a SaaS platform. You can try it out. We have a very good community. A lot of questions have been asked and answered. If you have more questions, feel free to ask that. One of us will answer that. And if you need to reach one of us for more discussion, feel free to reach out to either Kaz or me. We'll be happy to help you out. If you need more information, contact us. One of us will get in touch with you. Thank you again for joining us. Have a great day.